Okay, so here to get started today, we're talking about piecewise functions. We have this one up here. We're asked to do two things. We're asked to graph it, and we're asked to find f of 0. Of the two, probably graphing is the harder part, I would think. But so again, remember the big important thing to look at is that when you're going to evaluate or graph, we have to respect the domain here. Right? This says the graph looks like a piece of x squared plus 1 from -2 and to the left. Right? So again, it's just different pieces of different graphs. So with that, we do have some sort of prior knowledge here. We know that that is a parabola. We know that it does open up. So those are just some good basics to have. Let's then find some points on there. So if we look at just this top equation here, and again, I know that I'm going to have to include -2, and that's going to be a closed circle because it's got the equal part, right? It's an equality. So let's put in maybe -2 and -3 and -4. So let's see, -2 squared is 4, plus 1 is 5. And then -3 squared is 9, plus 1 is 10. And then -4 squared is 16, plus 1 is 17. Those points are all not going to make it on the graph, but it's nice to know they exist, I guess. Okay, we're up to 10, so we'll see what we get here. So we have a closed circle at -2, 5. Again, we want to kind of make sure our closed circles are obviously closed circles. We have a point at -3, 10. Right, and we know that the whole parabola would look like this, correct? Would have its vertex here at 1 on the y-axis. So kind of keeping that in mind, we can kind of help with the shape there. So we're just taking a piece of that. I would not, some people will draw the whole thing and then erase part of it. It doesn't seem to work that well for a lot of people. It seems to kind of confuse, actually, as much as it helps. Now for this second part here, this is just 4. It's just a constant, so that's going to be a horizontal line. And it goes from -2 to 2. So actually the only 2 points, this one I really need are going to be -2, 4, and 2, 4. Now those are both going to be open because it's a true inequality, right? There's no equal component to it. So I have a point at -2, 4, and that'll be open. And then I have a point at 2, 4, that'll be open. So it should be obvious here by our use of closed and open circles that if we, if we're asked what's f of -2, we would obviously go to the closed circle and say 5. Right? We wouldn't go to the open circle. Then our last part here is -2x squared plus 3. All right, well I'm going to start it, I'm going to do like 3, 4, and 5 and just see what I get. This parabola, we know it opens down, right, because it has the negative. The 2 means it's a little more narrow, which means it's probably not going to fit on my graph very well. And then the 3 just means it was shifted up 3 at the origin. So it probably looks something like this, right? But we're just going to look to the part of that to the right of 2, or actually, well that was weird, I guess but that's the thing here. Notice that it's undefined for the values from 2 up to 3, right? It's not defined by either of our inequalities. Now, I don't know if that was because I wrote it wrong. That would be because I wrote it wrong. But we could totally graph it. It's fine. This can happen, right? This can happen. That would still be an open circle. So in this case, if I put these numbers in here, 3 gives us -18 plus 3, which is -15. And 4 is -32 plus 3 is -29. Well, we can stop looking now. We know that's way out of there, right? So, all right. I guess we'll go ahead and graph what we have here. Let me extend this down a little bit. So -3. Or 3, -15, it'd be here. Now that was a closed circle, and that's going to go down to there, like that. closed. So that's what that'll look like. Now, in this case, if this is our function, which it is because I wrote it, if I did ask you to evaluate f of 2, right, does 2 fit in any of these intervals? No, so this would be undefined. Right? It's just not defined for this function. So I didn't mean for it to happen, but maybe it's like a happy accident, you know. So there we go. The next part is what's f of 0. So the first thing we're going to do is put 0 into the function called f. This is the function called f. And we know that 0 is between -2 and 2, correct? So that gives us the output will be 4. So once you do that, now you have f of 4. If we plug 4 into this function, it will luckily fall into here. Right? It didn't hit the missing spot. And then we see that that's actually going to be -29. Okay, so here's our next one we want to take a look at here, if we got a chance to try it. So again, kind of nice. We have 3 lines, right? You might hopefully notice that right away. Oh, and with these lines, I did put this here. It's probably in a bad spot. But if I look at these, just kind of take, it might be useful if you are having trouble to just sort of take each function individually, graph it, make a little table, kind of go from there. So if we think about 3/2 x minus 5, x is less than or equal to 2. So that tells us we have a closed circle at 2, correct? So for this table, I have to include 2. Okay. It's a line. I just need one other number less than 2. I'm not going to pick 1 though, because I have to do a fraction. So I'm going to pick 0 because it's just easier. So if we put 2 in here, we get -2 for y. If we put 0 in, we get -5. So again, this is a closed circle because of the equal part there. So 2, -2 is a closed circle, and then 0, 5 is just another point. So there's that. Again, it's going to the left. The arrow indicates it's going to keep going to the left. The next one we have is in the middle here is x minus 4. Where 2 is less than 7 is less than x. So for that, we know that we're going to have an open circle, right? It's going to segment with open circles on the end. And really, I just know I need to look at 2 and at 7. So I might just find those 2 values and then just plug them in. That'll give me a line. So here we get 2 minus 4 is -2. 7 minus 4 is 3. Oh, so 2, -2, we're back at that same point, correct? Okay, so there's an open circle there now as well, and then 3, 4, 5, 6, 7. Open circle there. Okay, so we get that. And it's good they shouldn't look straight because they do have different slopes, right? This one should be a little bit steeper, which it's marginally steeper, I guess. But the last one here is 2x minus 12, where x is greater than or equal to 7. So there I'm just going to put in 7, which I know will be a closed circle. I'm going to put in 8, which I know will be just a point on the line. So that's going to be 7, 2, and that's going to be 8, 4. Okay, so 7, 2, which we said would be closed. And then 8, 4 there. So it would look like that. So here we had an open and closed circle lined up. We just did a closed circle. Here we have actually a little bit of a gap there, a discontinuity. If you did, ask on this one, the domain is all reals, right? It's defined for everything, as opposed to the last one, which we left out, interval. The range would be all reals too, because we see it going up, we see it going down, so we're all set there. We also had this question, what's f of 8? Kind of fun. You get to use all the functions. So for that one, we do f of 8 first, which would be in this interval. So that's going to give us f of 2 times 8 minus 12. Again, I just plugged 8 into this rule. These outer 2 f's are just doing their thing. So that's f of 4, except, yeah, it is 4, right? Yeah, that's the same point we had over there, just to kind of verify. Now, when you do f of 4, well, 4 would be in this interval. Okay, so our rule would be 4 minus 4. So that would give you f of 0. Right? And then f of 0 would be this top rule, which would be negative 5. Oh, a lot going on there. Okay, for our next example, we want to take this absolute value function, figure out what it looks like first, and then write a piecewise function. Okay. Hopefully we can do this without having to resort to looking at a graph. This one we can. A couple of the later ones could be interesting, but got a few of these to try. So the first thing we want to do is figure out what in the world this looks like. Now, a couple ways to deal with absolute values. This is one we just got done talking about transformations, right? So you might be thinking, hey, it just moved 3 units to the right. There you go. That's fine. Another way, if you don't like that or that doesn't appeal to you, I just remember the vertex is always when you get a 0 inside the absolute value. So for me, even though I know the transformation, I still think, hey, I'm going to make a little table and I'm going to put 3 in the middle and pick a point above and a point below. That's going to give me the vertex, a point on each arm. I know it's V-shaped. There you go. So that would be 1, 0, 1. So our graph will look like this. Is that working for us? Now, I don't know if I probably didn't hit the right thing on the y-axis, which probably would have been nice to know. But in looking at this now, if we're going to write a piecewise function for this, it makes sense we're going to split it at 3, doesn't it? Like, because that's where, then we're just going to use 2 parts of 2 lines and we'll be fine. So, a couple ways to do this. If maybe go from left to right is fine. If you think about this right here, though, we just went down 1 over 1, correct? So it has a slope of negative 1. And then I also see it has the point, it has lots of points. It has the point 2, 1. I guess I could figure out what the y-intercept is if I really wanted to. I'm not going to. I'm going to do, I'm just going to take this point, which was 2, 1, and I know the slope is negative 1, and I'm just going to use the point slope form of the line. I think it's just good practice. So here it would be y minus 1 equals negative 1, x minus 2. So that would be negative x plus 2 plus 1, negative x plus 3. Does that seem like it probably would have hit a 3 if I would have figured it out? Yeah, that looks good. So we'll get negative x plus 3. Notice I don't put y in here because you already have f of x equals. So we'll get that, and that is going to be where x is, let's say, is less than or equal to 3. I could have put less than also. One of them is going to have less than or, the equal is going to show up at one spot because we have that same point there. So there's that part. Now the other part, if you want to look at that, we have, let's see, the point I see on there is 4, 1, and the slope is 1. Right, so again, the point slope form of a line, y minus y1 equals m, x minus x1. So y minus 1 equals 1 times x minus 4. So that's going to be x minus 4 plus 1. And that's going to be x minus 3. If x is greater than 3. So that would be how we could do that using piecewise functions there. And again, if you wanted to, we could have had this be less than 3 and this be greater than or equal to 3. The equal has to appear in at least one place. In this one, if you put it both places, it wouldn't be right. It would be okay. Probably not a great habit to have it both places. Because then if you want to evaluate, you'd have to look at both of them and make sure they match. Where if it's just one place, you just have to look at one equation. Okay, next up, we want to try to write this function. F of x equals the absolute value of x squared minus 2x minus 3 is a piecewise function. The first thing is we got to figure out what this looks like, okay, which is a little bit strange. So the first thing I do is I just want to figure out what this graph would look like in general, this parabola. Okay, so now if I do have that, remember the vertex of a parabola is always at negative b over 2a. Right, and that, if you think back to the quadratic formula, right, negative b plus or minus, and it's all over 2a. That's the vertex is always found there. So that's the x value. So this would be the opposite of negative 2 divided by 2 times 1. So the vertex would be at 1. Now, that is just if it's not absolute valued, right? But what I'm going to do now is I can make a table for the parabola without the absolute value, but then everywhere f of x is negative, I just make it positive, right? That's what absolute values do. Takes a negative, makes it positive. If it's positive, it just leaves it positive. So let's see, let's do maybe negative 1, 0, 1, 2, 3. Right? We know the vertex is at 1. That's something you should know, right? The vertex of a parabola is at negative b over 2a. So as we plug this in here, we get 1 plus 2 minus 3. I'm going to need a couple more points here. I don't have enough points. But let's go out a little more here. Sorry. Negative 2, negative 1, 0, 1, 2, 3, 4. So let's see. If I put negative 2 in here, that's going to give us 4 plus 4 minus 3, which would be 5, right? Is 5 positive? Yep. So it's still 5. Okay, and then negative 1 actually gives us 0, which is going to make it nice because we're going to get 1 minus or plus 2 minus 3, so that's going to be 0. Right, so 0 remains 0 if you absolute value it. We put 0 in here, we get negative 3, but then when we absolute value it, we get positive 3. Okay, and I'm going to put the negative 3 there, and I'm going to show you what the original graph would look like, and then what the absolute value does to it. If you put 1 in here, we get 4. Well, you get negative 4, which gives us 4 when we absolute value it. We put 2 in here, you get negative 3. When we do the absolute value, you get positive 3. Put 3 in here, we get 0. And then we get 4 in there, we get 5. So we have all that. And if we, again, let's graph it before the absolute value, because I can do that because I have a dry erase marker here. And we'll get rid of it. And this will help us too when we have to write that piecewise function, because a lot of it's just going to stay the same. But we have, if we just look at the original, so we have negative 2, 5, negative 1, 0, 0, negative 3, 1, negative 4, negative 3, 0, 5. So here, this would be the parabola, correct? Now, when we change it to absolute value, these points below the x-axis are now above the x-axis, right? So it's taking a parabola, and it's going to look like, it's just going to just swing it up to the top there. So these points won't actually be here. This will be 3, 4, 3. So again, this is coming down like it's a parabola. It's going to stop there. This is going up like it's a parabola. So that's just the original pieces of the parabola, correct? And this is the other part flipped over. So it looks like something like that. So that's what our graph is going to look like. Basically, again, it just takes the underneath part and just moves it up. Now, these are definitely points, correct? Those are corners. Later on, that'll mean something to us, and we'll care about that. But for now, it's going to help us draw the graph. Yeah, and a great question was asked here is that we really needed to know where the x-intercepts were at So you might have taken this and factored it to find where the x-intercepts are at, because that's where it's going to change from the plain old parabola function to this new function. It just got, the part that got flipped above the x-axis. So now as we go to write our piecewise function, the first thing you want to realize is this part and this part is just that parabola. Like, it didn't change. It's just that parabola. So we can start, we're going to be 2/3 of the way done pretty quickly here. Okay, and I'm going to we don't want to put the absolute value inside the piecewise. That would just kind of defeat the purpose. But we could say x squared minus 2x minus 3. And that would be if x is less than or equal to 1, negative 1. Right, that'll take care of this left edge. And I just went ahead and included the equals there just to take care of the point. Doesn't really matter. And then here we have x squared minus 2x minus 3 if x is greater than or equal to 3. So again, these are just the original, that's just the parabola that we started with, right? So this new parabola, what do we know about it? Well, it has a vertex at 1, 4. We know it opens down. I'm trying to think of the easiest way to write this. It's probably just going to be the opposite of what we had, isn't it? It's a hunch. I'm guessing it's probably going to be the opposite of what we had. So let's see if that's the case. So if we said, well, let's see, is it negative x squared plus 2x plus 3? So if I put 0 in here, I get 3, right? If I put 1 in here, I get 4. Right? If we put 2 in here, we get 3. Yeah, this is the same thing. I was trying to make it more complicated. So that would be the middle function, right? Because what did it do? It took what was below the x-axis and made it negative, correct? And we saw with transformations, if you make the entire function negative, it flips it over the x-axis. So from here, we would get negative x squared plus 2x plus 3. Negative 1 is less than x is less than 3 would be our piecewise function there. Okay, our last example here is we're going to write this as a piecewise function. This function's a little bit bizarre. I did go ahead and graph it on the calculator to see what it looks like. Do recall that if you need to type in the absolute value on a TI calculator, you'll go to Math, and then you'll go over to Number, which is the second kind of, I don't know what you call it, pull-down menu or something. Then it's option 1, which is ABS, in a parenthesis. That's your absolute value. So that's just a good thing to know. So as we look at this, we can see there's definitely 3 distinct parts here, aren't there? Now, this is horizontal and this is horizontal. So, and then this one, we know 2 points on it, right? Some different things there. So in order to find this equation, what we'll want to do is to write this as a piecewise. This is a horizontal at -5. So the output is -5 when x is less than, I'll just use a less than, and then maybe for this middle section we could use equal to. It doesn't matter. And this was at -2. So when x is less than -2, so I'm doing the leftmost end, and then I'm going to do the rightmost end, and I'll put that at the bottom. The output would be 5 when x is greater than 3. Was it 3 or? Yeah, it was 3. Again, this is the point 3, 5, and this is the point -2, -5. So now we just need to determine what is going on if -2 is less than or equal to x is less than or equal to 3. And even if I had no idea how to do that on a quiz or test, right? I have no idea. I've completely lost the ability to find equations of lines or whatever. I'd still put everything else here. And knowing that you're going to get most of the credit, you realize what the domain should be. You just, it wasn't your day, you know. So hopefully we can all find the equation of that line. I have a striking suspicion it's going to be like x minus 1, but I'm going to test it out. Oh, maybe not. 2x thinking 2x. So I'm going to find the slope because, see, my suspicion was wrong. Between these 2 points, we could actually do the slope formula, but we could realize that it just goes up 10 units. And it goes over 5 units. So the slope is 2. Okay. Pick any one point that I know on there. I'm going to take 3, 5. And then y minus y1 equals m x minus x1. And I would think, too, I could see giving you this picture on a quiz, right? Because obviously it's easy to, you could find the y-intercept on your calculator. But if you just had this picture, then you really don't know where it hits. So you'd have to actually use the point slope. Y minus 5 equals 2, x minus 3. So that's 2x minus 6, and 2x minus 1. Like we all suspected, right? So here we get 2x minus 1 is how we could write that as a piecewise function. Okay, so some things there. We talked today about kind of the absolute value, how you use it in your calculator, what it does, right, in terms of moving those values up. So, good stuff there.